Hello everyone, my name is Rutuja Vanzare, and as a part of an internship under the Sparks Foundation's GRIP December 2022, I have completed a task of prediction using decision tree algorithm, and I will explain it to you now. In this task, we are going to create the decision tree classifier and visualize it graphically. The purpose of this task is if we feed any new data to this classifier, it would be able to predict the right class accordingly. The data used for this task is a iris dataset. The iris flower dataset or Fisher's iris dataset is a multivariate dataset. The dataset consists of 150 samples from each of three species of iris: Iris setosa, Iris virginica, and Iris versicolor. Four features were measured from each sample: the length and width of the sepals and petals in centimeters. Based on the combination of these four features, Fisher developed a linear discriminant model to distinguish the species from each other. This is a classic classification problem we are going to solve with the use of decision tree classifier. First, what is decision tree classifier? Decision tree is a supervised machine learning algorithm that uses a set of rules to make decisions similarly to how humans make decisions. The goal of using decision tree is to create a training model that can be used to predict the class or value of the target variable by learning simple decision rules inferred from prior training data. To, Now, our objective for this class task is classifying new flower as belonging to one of the three classes present in the dataset. To perform this task in Python, we are gonna import the following libraries: pandas, numpy for calculations and model building, while matplotlib and seaborn will be used for data visualization. Now we are gonna load the dataset with pd.read_csv command, as I have already downloaded the iris dataset CSV file from the web. After that, we are going to form the iris data frame and create a target variable which is species. After that, I have performed some EDA, that is exploratory data analysis. Now, outliers or abnormal occurrences in a data set can have an impact on the accuracy of a machine learning models. The dataset might also contain some missing or duplicate values. Exploratory data analysis may be used to eliminate or resolve all of the dataset's undesirable qualities. After that, I've done some standard exploratory data analysis steps, seeing the shape of the data, seeing what columns are present in the data. Here we can see that ID column is unnecessary, so I'm gonna drop the ID column. After that, I have got the summary statistics of the data, where we can see the mean, maximum, minimum, standard deviation, quantiles, and count of the featured columns and target variable. Then I have seen the data types of the variables present in the data. After that, I have seen how many data points for each class are present in the data set. We can see that for each class there are 50-50 values present. So it is an ideal data set. Now, to know the missing values, I have used the data.info command. Here we can see, we already know that we have 150 data points in our data set. Here we can see that all 150 values are non-null for each and every feature and also the target variable. Again, to confirm our output, here I have used the isNull command. Here we can see that every column has 0 null values. That is, the variables have no missing values. Now I have now to visualize the sepal and petal dimensions. Here we can see that from sepal dimensions visualization, the iris setosa shown by the green dots has small sepal length. It's in the range of 0 to 5.5, while its sepal width is comparatively large. It goes from 3 to 4.5. It also, here from the petal width we can show that it has a really small petal length from 0 to 2. Also its petal width is really small from 0 to 0.5. Here for other classes we can see that it is very difficult to classify versicolor and virginica. They almost have same sepal dimension. Here it is easy to separate species Iris setosa from other two species with linear boundary, but it is not possible to separate these two with a linear boundary, and it requires complex memory for separation. But when we see at its petal dimensions visualization, we can see that Iris setosa has small petal length and petal width, while opposite holds true for the species Virginica. It can be observed that there is a linear relationship between petal length and petal width for all of the species. Here we can draw a linear boundary between these two also, and we can see that with increase in petal length there is also an increase in the petal width. After that, for analyzing the distributions of sepal and petal dimensions, I have plotted its histograms. Here from these histograms we can see that the sepal width has an almost a normal curve. Sepal length is lightly right skewed. We can't make any assumptions about the distribution of petal length and petal width just based on the histograms, as it does not have a definitive shape. Now I have analyzed the correlation between the feature and the target variables. Here we can see that there is a high correlation between petal length and petal width. Sepal length and sepal width are almost independent of each other, but sepal length has a high correlation with both the petal length and petal width. Now after that, I have split the data into training and testing dataset, because classification is a two-step process: learning step and prediction step. In learning step, the model is developed based upon given training data, and in prediction step, the model is used to predict the response for given data. Here there are 105 samples in the training set and 45 samples in the test set. After that, I have done some feature scaling. Standardization of dataset is a common requirement for many machine learning estimators. They might behave badly if the individual features do not more or less look like standard normally distributed data. After that, sorry, After that, I have built a decision tree classifier with the use of sklearn library. Now fitting the model to the trained data, I have used the command decision tree classifier .fit. Here we can see that the accuracy of decision tree I have created is 0.97. Accuracy is a ratio of correct predictions to the total predictions. The accuracy of model is almost 98%, which means that the model performs accurate results 98 times out of 100 times. And from this confusion matrix, we can see that only one observation was classified as a false. Now to visualize the model prediction results. Here is my decision tree created from the training dataset. In decision tree chart, each internal node has a decision rule that splits the data. Here we can see the splitting. Gini referred as the Gini ratio, which measures the impurity of the node. You can say the node is pure when all of its records belong to the same class. Such nodes are known as leaf nodes. Here we can see that the impurity index, that is Gini ratio, is almost 0 for every leaf node. But the resultant tree is unpruned. This unpruned tree is unexplainable and not easy to understand. In next section, let's optimize it by pruning. The decision tree is good, but its length is really high. In scikit-learn, optimization of decision tree classifier is performed by only pre-pruning. The maximum depth of the tree can be used as a control variable for pre-pruning. Now, Here we have used the criterion entropy and maximum depth 3 for the pruning. Here we can see that even after pruning, the accuracy of the model has not changed. But here we can see the difference in the width and length of the decision tree. This pruned model is less complex, explainable, and easy to understand than the previous decision tree model plot. This is how I have completed my task. Thank you.